Okay, you are working now with a different kind of measurement for angles. You're used to degrees, but now we're going to start talking about radians. And radians have an advantage because we don't put necessarily the unit as if it was something special like a degree or an inch or a foot, but it is typically denoted as the same kind of units as you would have on the number line, representing one. 1 radian would be like one whole number, but you'll find that out a little bit later and such. Now they ask in the first two questions for you to define a radian, to define a degree, and both of these are in the note page that they gave you, so if you don't like anything you come up with, you can look at the notes and see what he uses. But for a radian, this is the way I always try to tell my students. Notice here I drew an angle whose vertex is at the origin. The initial ray is the positive direction of the horizontal axis. I didn't mark it red, it's just this part of the number line here. And then the terminal ray is this one here that's in red. And the angle, notice, is counterclockwise. In trig, counterclockwise is positive measure. And notice here that I say that this distance here is r, which represents the radius of this circle that I've drawn here, whose center is at 0, 0. So this central angle, this measurement right here, this is r, this is the radius of the circle. If this distance here is the same as this distance s, which is the length of the arc, if they have the same measure, if the radius is equal to the length of the arc, then this central angle here, central angle, remember, vertex at the center, is 1 radian. And it turns out it's just a little bit less than 60 degrees. Because as you might imagine, if it was 60 degrees, then the line segment from that point to that point, it would have to be the same length as r, because then you would have an equilateral triangle. But it can't be because we want this to be equal to r. So it's a little bit smaller than 60 degrees, like 57 degrees approximately. Alright, so anyway, that's 1 radian. A degree, you can think of a degree as if you take a circle and you look at the central angle and you break the circle, the circumference of the circle up into 360 individually equal size little arcs or arclets or whatever you want to call it. So it would look so small I probably can't even hardly show you the difference between where this line is here and where that's at. But this angle that would be formed here would have measure, if it's 1/360th, it would have measure 1 degree, because we know a complete revolution is 360 degrees. Then the rest of the assignment is just converting. You're converting angle measures that are in degrees to radians or vice versa. And he gives it as 2 different little ways to do this. I usually use 1, but that's okay. We can go with what the guy says because I want you to be consistent with his work as well. But what he does is he takes, anytime you have a measurement in degrees and you want to change it into radians, then he has you multiply the fact. Now remember, this is going to be a little tricky for you right now, that the distance around the circle, the circumference, okay, now if that is s here and that is just a little bit under, like 1 radian, and it's a little less than 60, then we would have a little more than 6 radians all the way around. In fact, we would have 2 pi, which is 6.28 approximately. So all the way around a circle, 360 degrees, is equal to 2 pi radians. You got to memorize that one. 360 degrees, 2 pi radians, which means half of each, 180 degrees, and 2 pi, half of 2 pi is pi. 180 degrees is the same as pi radians. So he's going to use this ratio of pi over 180, because if the 180 degrees, because if these are equal measurements, then this is kind of like you're multiplying by 1. But all it's doing is it's just having you be able to use a little dimensional analysis to rewrite this. So all we're going to do is multiply. That's why I put the 210 over 1. We're going to multiply 210 degrees times pi over 180. Well, before I multiply numerators and denominators, I look to see if anything cancels. I can divide both here and here by 30 degrees. 30 goes into this 6, 30 goes into this 7. So now I multiply the numerators, that's 7 pi, and I multiply the denominators, that's 6, and that's my answer. Now, unless he tells you to, you don't have to write down radians next to it, because if there is no unit measure there, it's implied to be in radians. So that's what I'm going to do for the next 7 problems. I'm going to take each one of these and I'm going to multiply by pi over 180 degrees. So I just put it over 1, and I look for the biggest number that might divide into both to simplify this, and I can see 20 degrees goes in this 9, 20 degrees goes in this 5. 5 times pi is 5 pi. 1 times 9 is 9, so my answer is 5 pi over 9 radians. I do the same thing here, multiply by pi over 180 degrees. So again, I'll put it over 1, this is times. And I look for the biggest number that will go into both. And actually, I think the biggest number that goes into both would be 5 degrees. 5 goes into that 36 times. 5 goes into that, 5 degrees goes into that 29 times. So I end up with 29 times pi all over 1 times 36, which is 36. All right? Next guy up. I have 300 degrees. I'm going to change this into radians by multiplying it by pi over 180. Okay? Now, 300 degrees times pi over 180, if I put it over 1, I look for the 180 degrees. I look for the biggest number that goes into both, and I'm thinking it's 60. 60 degrees goes in this 3 times, 60 degrees goes in this 5 times. 5 times pi all over 3 is 5 pi over 3. Okay? Same thing here, I'm going to multiply this by pi over 180. This is getting monotonous probably to you right now. 50 is like 50 over 1. I look for the biggest number that goes into both. I'm thinking 10 degrees. 10 degrees goes in that 18 times. 10 degrees goes in that 5 times. So that's 5 pi over 1 times 18 or 18. 5 pi over 18 radians. This guy here, now think about it. If 360 degrees is 2 pi and 180 degrees is 1 pi, then half of 180 would be half a pi. I'll bet you a quarter this turns out to be 1/2 pi or pi over 2. So I multiply it times pi over 180. I'll put this over 180 degrees. 90 degrees goes in that once, 90 degrees goes in that twice, and pi over 2. And we normally say pi over 2 instead of a half pi. It's just kind of traditional. Now I've got 2 more of these, but they're both negative. That just means my answer in radians is going to be negative. You do everything exactly the same. I'm going to multiply this by pi over 180, 180 degrees. Put it over 1. I look for the biggest that goes into both. I'm thinking it's 30 degrees. 30 degrees goes into that 6. 30 degrees goes into that negative 5 times. So it's negative 5 pi all over 6 like that. And if you don't want the negative up top and it looks cooler if you put it in the middle, you can write it that way as negative 5 pi over 6 radians. One more like this. I'm going to multiply this times pi over 180. Put it over 1. Negative times positive. I know it's going to be negative. I look for the largest 180 degrees, the largest amount that goes into both. I'm thinking it's 20 degrees. Goes into that 9 times. 20 degrees goes into that negative 13 times. So it's negative 13 pi over 1 times 9, or negative 13 pi over 9. Okay? Now, we just reversed this for the next, what do we have here? The next 8 problems. We're going to kind of reverse this by changing radians into degrees, and you will need your degree symbol for your answers. Now think about it. If I multiply by pi over 180 to change degrees into radians, I'm going to multiply by 180 over pi. I'm going to multiply each one of these by 180 degrees all over pi. And as you can see here, pi goes in that once, pi goes in that once, right? And I can see 9 goes into 9 once, 9 goes into 180 degrees, 20 degrees. So that's 8 times 20 degrees all over 1. That's 160 degrees over 1, or just 160 degrees. And don't forget your degree symbol. You don't have to put it over 1, we'll just go from here to here. So I'm going to do the same thing here. I'm changing radians to degrees. Now notice, the one that I'm changing out of, the one that I'm starting with, has to match the units in the denominator. Here they're both degrees. This the degree here from the original problem and the degree in the denominator. Here, radians and radians in the denominator. The pi's in the denominator. That's what it's going to tell you. Okay, because you want that canceling effect. You want to cancel out the radians and end up with degrees. So this one is going to be times 180 degrees all over pi. The pi's cancel. And now I can divide 12 into both of these. 12 goes in that once, 12 goes in that 15 degrees. So I have 7 times 1 times 15 all over 1. That's 105 degrees. And 6 more just like this. They're going to work just like this. I do have a couple of negatives. So times 180 degrees all over pi. The pi's cancel. 18 and 180. 18 goes in that once. 18 goes in 180 degrees, 10 degrees. So that's 29 times 1 times 10 degrees all over 1. That's 290 degrees. Okay, times 180 over pi. 180 degrees over pi. I notice the pi's cancel. 2 goes in the 2 once. 2 goes in the 180 degrees, 90 degrees. So this is 3 times 1 times 90 degrees all over 1, or 270 degrees. And these last 4 are kind of the same, times 180 degrees all over pi. So pi goes in that once, goes in that once, and then I can divide by 12 into both of these. That might be the trickiest thing, is simplifying it. Make sure you get simplified lowest terms. 12 goes into 12 once, 12 goes into 180 degrees, 15 degrees. So that's 1 times 15 degrees all over 1 times 1. So that's 15 degrees. Down here, times 180 all over pi. Okay, 180 degrees over pi. The pi's cancel. 12 goes into 12. I just did 12. 12 goes into 12 once. 12 goes into 180 degrees, 15 degrees. So it's 5 times 1 times 15. That's 75 degrees over 1, or 75 degrees. All right, now these are going to both have negative answers because the original angles are negative radians here. So I multiply by 180 degrees over pi. The pi's cancel. And 3 goes into 3 once. 3 goes into 180 degrees, 60 degrees. So I have negative 5 times 1 times 60. That's negative 300 degrees all over 1. And last but not least, I multiply by 180 degrees all over pi. The pi's cancel. And 3 goes into 3 once. 3 goes into 180 degrees, 60 degrees. So that's negative 2 times 1 times 60. That's negative 120 all over 1. It's negative 120 degrees. Now, the last, how many you got? The last 8 problems are just like these problems, except that some of them are mixed in. They have some radians, then they have some degrees, and vice versa. So after seeing this, you should have this one under control. This is a pretty straightforward lesson. He could have gotten into this a lot deeper. However, you need to know how to do this because you're going to be dealing with angles that are in degrees and in radians. So I'm guessing he's going to be doing some stuff with graphing. He's going to be doing some stuff with solving equations that involve trig functions. So we're not done with this guy by any means. We're going to need to know degrees and radians on your calculator. Your mode can go from degrees to radians, and in some calculators to gradients, which is a third way to measure angles. So you're going to need to be able to do this stuff, and you need to know how to multiply by either 180 degrees over pi or by pi over 180 degrees. All right, good luck with that assignment.